And welcome back to the Kennedy Space Center, where we are currently awaiting the second burn of the second stage of the Falcon 9 rocket, and then separation of Firefly's Blue Ghost lander from that second stage rocket. It lifted off at 1:11 and 39 seconds a.m. Eastern Time. I am joined by Ray Allensworth. She is the Spacecraft Program Director at Firefly. Been doing a fantastic job. We watched the launch live. It took off. You said, bye, honey. This is a spacecraft you've been working on for so long, and then you saw it take off, and now we've been flying for about 47 minutes. What's your sense of how the team is doing, and how are you doing at this point?
My heart rate's come down a little bit. It's definitely very special to see it go. I think the team now, especially that team back in Texas, really this is where they're locking in. So, you know, we're about to go into payload deployment. The lander's powered off right now, but it will soon start that automated sequence to power on. So this is really where we start. So just a lot of anticipation building.
A shot on your screen now of that team that you're talking about from just outside Austin, Texas, the Firefly Aerospace Mission Operations Center. And the team is all there and, as you say, focused on the next steps. The company is, of course, based in Texas. They developed and built the lunar lander that is carrying, among other things, 10 NASA payloads. And if everything goes as planned, in 45 days, that Blue Ghost lander, which is uncrewed, there are no people on board this is purely a robotic mission. If everything goes as planned, it's going to land on Mare Crisium in the northern hemisphere of our moon. It's an area that, of course, NASA wants to study and was chosen specifically for that reason.
Yeah, absolutely. That place, you know, Apollo has visited there. We also believe future missions will want to go back there. So it's a really important place to go, gather data, and just prepare for what's next.
We still have a few more NASA payloads to cover throughout the show. We've talked about 8 of them. And now, finally, the last 2.
Last 2.
You ready? All right. Let's talk about it. And it starts with LUGRA, an acronym for Lunar GNSS Receiver Experiment, which was developed at Goddard Space Flight Center. LUGRA is one of the very first demonstrations to test GNSS signal reception and navigation on the lunar surface, right? These are satellites going around the Earth, but we're using them to develop location on the moon. GNSS is the Global Navigation Satellite System, which is commonly thought of as GPS. Of course, that's the American Satellite System nomenclature for it. If successful, this would pave the way for operational use by future lunar missions such as the Orion spacecraft, the planned lunar orbiting station called Gateway, and robotic and human landers. Ray, of course, Blue Ghost is using different navigation to get there, but imagine if you could use GNSS.
Yeah, that'd be really amazing in the future. You know, quite like use your phone, pull up Apple Maps, Google Maps. You want to put in a place, you go exactly there. That's the future of what could happen on the moon.
And that's pretty cool. That would be an advantageous thing for anything going to the moon, right? How did you get this mounted on the spacecraft?
Yeah, so LUGRA is mounted on our top deck. It's on one of those two-axis gimbals. So LUGRA shares a panel with NGLR. And this is a really special payload. This was in partnership with the Italian Space Agency. And so, yeah, we're excited to have that and get it operating.
First equipment for the Italian Space Agency to have on the surface of the moon. We know they are very excited about this. Let's talk about our last payload now, the final one. This one really kicks in right about the end of, right when they were landing, right? As it kicks up a plume. It's SCALPS, and it stands for Stereo Cameras for Lunar Plume Surface Studies. It was developed at NASA's Langley Research Center in Hampton, Virginia. SCALPS is an array of cameras placed around the base of the lunar lander to collect imagery during and after descent. Those images will then be compiled to produce a 3D view of the surface, and not just for the novelty of it. As trips to the moon increase, the number of payloads touching down in proximity to one another will also increase, and you see it there as it's mounted on the Blue Ghost lander, and now you're seeing an animation of it landing. Scientists and engineers, they need to be able to accurately predict the effect